Hello. In this in-class activity, we are going to demonstrate how to express probabilities in mathematical notations. Now, this is not a very difficult task, but still there are a few things that I like to emphasize, I like to point out, so that the student can express probabilities correctly. First question, the probability of getting a red ball is 20%. This is a straightforward expression. We know the letter P here means probability. Getting a red ball is a statement that the experiment. We put this statement within a parenthesis. The probability values can be expressed as a percentage, a fractional value, or as a decimal value. Question number 2. The probability of failing a statistical class at SIUE is 3.3%. Now here, failing a statistical class at SIUE is a kind of short statement. Sometimes students want to make the statement very succinct, but you cannot make the statement too short because you may risk to make the expression less clear. For example, if you only say failing a class, that makes not quite clear what kind of class and what at where, because depending upon classes, they may have a different probability of failing rate. Also, at what institutions, they may also have a different failing rate. So really, you have to make sure to tell the reader what is the class involved and also at what institution. So you want to make the statement succinct, but you cannot make it too short to lose the clear context here. Question number 3. Toss a coin 1,000 times. Heads appear 495 times. Now you can express this probability in a fractional numbers, but you have to make sure to simplify 495 over 1,000 to 99 over 200. Alternatively, we can simply express these probabilities as a percentage number. Question number 4. 25% of students in the class get a grade better than B. Now, this statement actually tells us a interval probability, because here the statement grades higher than B includes not just one grade. It includes B plus, A minus, and A plus. It involves a interval. So this statement actually, the statement grades higher than B is actually tell us a interval. The interval, one end of interval is B, and the other end is go B plus, A minus, A plus, so on and so forth. Okay. So now we begin to see the statements that express an interval. So this probability actually expresses the probability of an interval. Now this expression can be alternatively expressed as probability for grades better than B, because B plus A minus B, A plus is all better than B. Okay. Question number 5. A variable Z has a 34.5% probability of taking a value larger than 1.56. Again, this is a statement that expresses a interval similar to the last question. Therefore, we can use the expression similar to the one that we used in the last question. Z probability for Z larger than 1.56 is 34.5%. But also we can use the interval notation to express this probability more succinctly. And this is a more common way to express the interval probability. Look at this. The probability for Z larger than 1.56. Here we use the inequality sign larger than to express an interval. Now, for this interval, the low end is 1.56, and from 1.56 you go all the way to the infinity. So this is again we express interval probability by using the interval notation here. %32% of SIUE students are aged between 20 and 25. Obviously, this is another statement that shows an interval. For this interval, we have two ends. The lower end is 20, the higher end is 25. So when we come to express this probability, we use this interval notation. The student age is larger than 20 and smaller than 25. We follow the convention that we place the smaller value to the left, place the larger value to the right when we express this interval notation. Now, some students like to use a more succinct expression, and some students may use such expression as the probability for A lie between 20 and 25 equal 32%. It's okay if you want to use expressions such as this, but if you introduce notations such as A in the expressions that not explicitly defined in the question, you need to make sure that you clearly define what this A means. You see, in the question itself, it does not give a definition that says what is the A. Therefore, if you want to introduce your own notation, you need to define it either before or after the probability statement. Question number 7. Approximately 25.31% of the values for a variable t are larger than 3.5, and 13.65% of the values fall between negative 3.4 and negative 2.8. Now, this is a kind of loaded question. Let's break it down a little bit. We have a variable that is defined as t. Then we have this interval. This interval says that the t values larger than 3.5. Obviously, this is a one interval. And the probability for this interval is 25.31. So this is one probability expression. Then we have another interval for the variable t. And this interval falls between two values, negative 3.4 and negative 2.8. So this is the second interval. So you need to write the second probability expression for this second interval. Okay. So now let's look at how do we express the probabilities for these two intervals. You see, the first statement, the probability for t larger than 3.5 is 25.31%. So this is the first interval, probability for the first interval. Now for the second expression, the t fall between negative 3.4 and negative 2.8. You know, the value negative 3.4 is smaller than the value of negative 2.8. That's why we place the negative 3.4 to the left and the negative 2.8 to the right. And then we use the inequality sign to connect them to express this interval, the t fall between these two values. Question number 8. Of all the values of a variable, 4.6% are smaller than 67 and 24.6% fall between 50 and 86. Now for this probability statement, in the question we say that of all the values of a variable, we really did not give the notation for the variable. So if you want to express this the probability statement succinctly, you may want to introduce some definitions here. So we first define the variable as n. After this, we can use this notation in our expressions of probability to make the expression succinct. The probability of this value m smaller than 67 is 44.6%, and the probability for this variable fall between 50 and 86 is 24.6%. Again, we follow the convention to place the smaller value to the left and the larger value to the right. Question number 9. In a symmetrical distribution, the variable x has a mean which is 78. Half the cases in variable x have a value larger than the mean, and half the cases have a value smaller than the mean. Now we can directly use the x in our expression, because in the question the meaning of x is given. So this is a pretty straightforward expression. Question number 10. Of a city's total population 21,450, 3,340 are older than 65. Express the probability of being a senior citizen in a city in mathematical notation. Now one way to express this probability is probability being a senior citizen is 3,340 over 21,450, and you break that down, you eventually express that as a percentage number. Alternatively, you can make a slightly different statement: probability of being older than 65. So depending upon your personal preference for the same probability statement, you may come up with a slightly different expressions. I hope this helps. I see you next time. Goodbye.